Algebra 2 students, Mr. Shack again. Uh, this is now the Module 5 test review. So it feels like I'm kind of recording these almost every other day at this point because you guys are testing every single week. So uh, let's just make sure we get through this. I'm not going to be able to do every single one of these problems because I found out the hard way on the last video actually that I get cut off at 30 minutes. Which that's fine because I really I need to get this done kind of within that time anyways because I have students coming to class. So sorry, someone was looking for me at my door, but I think we're good. So I'm gonna crank through this. I circled all of the ones and then that I'm gonna do on this video, and the ones that aren't circled, I will tell you that they're very similar to blank that I already did. So if I'm not going through it, it's because it's very similar to one that I already have gone through, and I will of course post the answer key also, so you can hear me talking through one that's very similar on this video, and then you can try that one on your own, checking your answer. I'll have my work on my answer key and everything for you there. So let's get going. I can't waste too much time. So number one, we have what are the rational zeros of the function 3x squared plus 21x minus 90? And really with this one, you're always looking if there's a GCF that you can factor out, so the greatest common factor. These all are divisible by 3, so that's just something you got to recognize. And then if you pull a 3 out of 3x squared, well, that's just x squared. Pull a 3 out of 21x, well, that's 7x. Pull a 3 out of 90, well, that's 30. So then you got the 3 out, and then you're looking at this, and you're looking for something that's going to, and if you need to make your x, you can. It's got to multiply to negative 30 times 1 and add to 7. Okay, and the two numbers that do that are 10 and negative 3. So that means your factors are x plus 10, because your a is 1 here, so it's just 1x plus 10, and x minus 3. Those are your factors, and we can't forget this 3 out front. But then you're thinking, okay, well, your solutions or your zeros are whatever is going to make this 0. Well, that's negative 10. And what's going to make x minus 3 equals 0 is a positive 3. So your answers are negative 10 and 3 for that one. Moving on, and again, if I go too fast, which I probably am, make sure you're pausing, rewinding, thinking about what I'm saying, thinking through each of these problems. So number 2, we have a function that they're giving us, and they're giving us the first two binomials that this factors out to, and it wants us to tell them the third. So how you're going to tackle any problem like this, and there's one that's very similar to this that I'm not going to go through on this video, is you're looking at the binomial that just has a single x. Like, see how this is 4x? Nope, I'm not going to use that. I'm going to use this one because it's just an x minus 2. And then I can use synthetic division with this. And I'm thinking, okay, well, what makes x minus 2 equals 0? That's a positive 2. So I throw that up in the box. And now when I do the synthetic division with this, it's going to pop out a trinomial that I can then factor to find my last factor. So you'll see what I mean in a second. So let's follow along. I have 12x cubes, 12x to the thirds, in other words, negative 19x squareds, negative 12 single x's, and then 4 is my constant. I don't know why I wrote the x. You never write your variables in synthetic division. And then I just go ahead and hopefully we're good at this by now. I drop down the first. 12 times 2 is 24. Negative 19 plus 24 is 5. 5 times 2 is 10. Negative 12 plus 10, negative 2. Negative 2 times 2, that's negative 4. Boom, no remainder. Okay, now I know I went really fast there, but you just got to remember you're adding straight down and you're multiplying whatever you get down here to the guy in your box. So if I went too fast, pause it or rewind it and think about what was going on there. Okay, so then if I get this as my answer, remember it started as degree 3, so once I divide it by a binomial, it's going to become an x squared, or degree 2, I should say, a quadratic. So I now have 12x squared plus 5x minus 2. Okay, and then I need to factor this. So in order to factor this one is one where I really do need to use my uh, X model or diamond model, I've heard it called. But it's got to multiply to a times c. Well, my a is 12, my c is negative 2. So it's got to multiply to negative 24. 12 times negative 2, that's the negative 24. And it's got to add to our b, which is 5. Okay, so I'm thinking of, okay, well, what multiplies to negative 24? And then it also has to add to 5. And what you should come up with after thinking, think a little bit, pause this. Don't let me just give this to you. Pause. Okay, hopefully you paused and now you see that it's negative 3 and a positive 8 is what adds to 5 and multiplies to negative 24. Now remember, we have a 12x squared, so I need to put a 12x plus 8 and 12x minus 3. And then here, these can both be divided by 3. When I do that, I get 4x minus 1. Okay, look at that. That's their factor they already found. So this one should give me the other binomial that they were looking for. Both of these can again be divided by 4. There's only 3 here, so not again. But these both can be divided by 4, and that'll give me 3x. 8 divided by 4 is 2. So 12 divided by 4 is 3, so 3x, 8 divided by 4 is 2. 3x plus 2, that is my third binomial that they wanted. That's my answer, 3x plus 2. Okay, moving on to number 3. This is something that in order to get started on, you really just have to put this guy into Desmos. So I guess I can switch over and show that quick. Hopefully I have time. Okay, so I'm putting in 3x cubed plus 7x squared. X cubed plus 7x squared minus 22x minus 8. Okay, and when you do that, you got to find the one or two. Good, there's two. There are two rational zeros or whole number zeros. So I can really pick which one I want to use. I'm just going to use the negative 4 over here, okay, because that's where my cursor is now. So I'm going to change it back over here. So I see that it goes through negative 4. Now, once I see that, and it's really asking, well, what are the sum of my zeros? So I need to know all of them. I already know 2 are negative 4 and 2. And then I'm just choosing to use negative 4 for my synthetic division. And then it's just going to be the same thing as when we did synthetic division up here. So I'm going to go really fast. My coefficients are 3, 7, negative 22, and negative 8. Okay, drop down the 3. 3 times negative 4 is negative 12. Add those, that's negative 5. Negative 5 times negative 4, that's 20. Negative 22 plus 20, that's negative 2. Negative 2 times the negative 4 is a positive 8. That gives me a remainder of 0. Again, I know that was fast, but I just did it here. Rewind it if that was way too fast. It probably was. So go back and look. Okay, but here are already 2 of my zeros that I saw on the graph. And really, the graph gave me my other one. I saw it was negative 0.33. So we should see how we're going to get that. Let's write this out. If it was an x cubed here, it's going to be an x squared, minus 5x. I'm just using my answer from my synthetic division, minus 2. Okay, and now I'm trying to factor this. So if I'm factoring this, I know it needs to uh, multiply to c times a, negative 2 times 3, that's negative 6. It's got to multiply to negative 6. It's got to add to my b, which is negative 5. Okay, pause, think about what those two things are. You should get 1 and negative 6. and it's a 3x out front, so it's 3x plus 1, 3x minus 6. Okay, when I do this, I can divide both of these by 3, so that really becomes an x minus 2. Boom, that's going to, well, you're thinking, what is going to make x minus 2 equal 0? Well, that's positive 2, so that's why we saw that on the graph. And then here, to find the last one, 3x plus 1, you got to just set it equal to 0. Solve for x, you subtract 1 from both sides, you get 3x equals negative 1. Divide both sides by 3, you get x equals negative 1/3. So that is my third zero, and we did see negative 0.33 repeating on our graph. So, yep, there it is. But you got to show me some work here. Just don't do it all on Desmos. Do something like this, and you know you did it right if you get that last one that you saw. And then this one is asking for the sum of the zeros. So the sum, that just means I got to add all of these up, and when you do that, you should get negative 5/3. Okay. So that is your answer there. I'm hoping we know how to add these things up. That's something I shouldn't have to show, because that's something I taught when I taught 6th grade last year. So I hope we can do that part. Moving on to number 4. Now, if I have a polynomial with roots -2, 0, 3, and 7, well, I got to think about what that's going to look like. It's really, I take the opposite of each of these. If I have a root of -2, that means I have an x plus 2. If I have a root of 0, well, then that just means there's a lone x out front. And then if I have a root of 3, that means I have an x minus 3. If I have a root of 7, that means I have an x minus 7. Okay, because 7 is what makes this 0, 3 is what makes this 0. So that's how I knew how to set all that up. And now from here, I need to multiply this out, because the way that it gives you this test question on your test is, I think it's a multiple choice, and it gives you all of them in standard form. So they're not in this form. You need to multiply it out to get it into standard form. So here's what I mean. Well, x times x is x squared. X times 2x is 2x. Okay, so we can go ahead and combine those two, right? That's multiplying those two out. And then we can go ahead and we can FOIL with the next one. So let's do that. X squared times x, that's x cubed. Okay, 2x times x, that's 2x squared. I'm just foiling really right now. 2x squared. Okay, x squared times -3, that's a -3. X squared. And then 2x times -3, that is -6x. Okay, then I just need to combine my like terms. And what I get, I'm going to put over here. When I combine my like terms, I get x cubed minus x squared, right? 2x squared minus 3x, that's a minus 1x squared, and then minus 6x. And now lastly, I got to multiply it by my last binomial over here. So I'm going to go ahead and line this up so I can make my box. That's how I'm going to multiply out this last one. And if you didn't like doing the FOIL here, you could have really done a 2x2 box with these two also, and then you would just have to go ahead and take the answer that you got, put it on a 3x2 box to multiply it by the last thing. That is totally fine. When you do this, then x cubed times x to the first, that's x to the fourth. -7 times x cubed, -7x cubed. Negative x squared times positive x squared is negative x cubed. -7 times negative x squared. Negative times a negative makes a positive, and that's an x squared. -6x times x, it's -6x to the second, or 6x squared. And then -7 times -6, that's positive 42, and then there is an x here, so we got to tack on the x. Combine all of these like terms, okay? And here's what you should get. X to the fourth. Combining these gives you, this should be a -7x cubed. I just caught that. So -7x cubed minus 1x cubed gives you -8x cubed. 7x squared minus 6x squared, that is just a positive x squared. And then just a 42x at the end. So when you are given this problem, this is what you're going to have to do, multiplying all of these out. because it's going to be a multiple choice given to you in standard form, so you need to be able to find it by multiplying them out. Okay, this one, number 5, very similar to number 3, except it's not asking for the sum, it's just asking for all of the roots. But same deal. You first put this into Desmos. Okay, put it into Desmos to find one of the roots. When you do that, I will just tell you you should find -5 to be 1. Okay, and you also should find 2 to be 1. That's the other rational root. And you could use 2 as the guy in the box. You're still going to get the same answers when all said and done. But if you see -5 as 1, that's what you're using to do synthetic division. Now, you have 1x to the 4th, 3x cubes, -17 x squareds. Okay, hopefully we're used to me saying x to the 3rd as x cubed, x to the 2nd as x squared. There's -21 x's and 70 nothing. Just 70 constant is your constant. Okay, then synthetic division. I'm going to do this really fast again. Bring the 1 down. 1 times -5 is -5. 3 plus a -5 is -2. -2 times -5 is +10. -17 plus 10, that's -7. -7 times -5, that is a 35. -21 plus 35, that's 14. 14 times -5 is -70. There you go. You don't get a remainder here. So now I'd write this out as x squared minus 2x, x cubed, because it starts as an x to the 4th. That's my bad. Since we are dividing an x to the 4th, it goes down to an x to the 3rd. You just subtract 1. Okay, and now I'm subtracting 1 as I go down 1 each time. Now this -7 is going to be an x to the 1st, or just an x. The 14 is just going to be my constant. And now here, when you're left with a 4-term polynomial here, that's when you know you're probably going to be factoring by grouping. So let's look at these two separately. The biggest thing I can take out of both of these is just an x squared. Then I get x minus 2 when I divide both of these by x squared. Okay, here I can pull out a -7 from both. When I do that, I get just an x. 14 divided by -7 is -2. So do we see the factoring by grouping here? I get x squared minus 7. I'll come and write it over here. X squared minus 7 times x minus 2. That's what you should get, right? X squared goes with the -7, and then you get your pair of x minus 2. So now you should start seeing as your roots, you get x equals +2. You got the original one that we saw in the graph. I didn't show this, but remember, you'd put this into Desmos. That's how you'd start it. And we saw -5 to be 1. Okay, so +2 comes there, right? Because 2 makes this 0. -5 is the one we saw in the graph. And now I'm thinking, well, what is going to make x squared minus 7 equal 0? And I can just go ahead and solve it for x once I set it equal to 0. So I add 7 to both sides. I get x squared equals 7. In order to get x alone, now I have to square root both sides. So my final root is x equals plus or minus square root of 7. Right? Anytime you're taking the square root of something, have to tack on that plus or minus. And it is a never-ending decimal, so if you just leave it as root 7, that works for me. All right, let's keep going. We're starting to get into a lot of repeats. 6 is the exact same as 5 that I just did. Okay, you have to put this into Desmos, find your first root that you see on the graph, put it up here, synthetically divide. When you do that, you're going to get a 4-term polynomial again, factor by grouping again, and then again, you will find your roots. Okay. In this one, you're going to have one double root, so there will be a double root here. I'm going to make note of that. And when you put this into Desmos, you should, Probably couldn't see this whole time. When you put this into Desmos, you should see the double root right away, because anytime you hit the x-axis and it bounces right off instead of crossing, we say it's tangent. And if it's tangent, well, then that means it's a double root. Okay. Same thing with number 7, except notice something about number 7 here. It's asking for the rational zeros, and I circled it because it is a little bit different, because looking at this, there's a greatest common factor, a GCF, that I can pull out right away. These all have at least an x squared in them, so I'm going to pull out an x squared to start this. X to the 4th divided by x squared is x squared. Negative 6x cubed divided by x squared, well, that's just negative 6x. And then 9x squared, pulling out the x squared, is just plus 9. Okay, and now this one actually turns out pretty easy, because I have x squared as one of my factors, and then factoring this should be pretty nice and easier. I'm thinking of two things that multiply to 1 times 9. So multiply to positive 9, add to negative 6, and you should see that it's x minus 3 and x minus 3. Okay, and if you're thinking of it this way, multiplies to 9, adds to negative 6, you get minus 3, minus 3. So that's what you get. So here, again, you have a double root. You see that x equals 3. You can write it again, or just point to 3 and say it's a double root. Okay, and then you also get, well, what's going to make this equal 0? It's just 0. 0 squared is 0. Okay, and the reason we get 2 3's is because, well, 3 minus 3 makes this 0. 3 minus 3 also makes this 0, so you get 2 3's double root there. Okay. Number 8, this one is extremely similar to number 2. So go back, see what I did for number 2. You're doing the exact same thing there. Number 9, very, very similar to number 6 and number 5. So you're looking at the graph to find your first root, and then that's going to be what you put up in the box. Synthetically divide out, factor the last one. You will find your roots then. Okay. This one is going to be multiple choice on the test, and really it's asking what is a root. You can just put this into Desmos. You should be able to see which one is a root looking at your options. So put this into Desmos or your graphing calculator. You can then see all your roots, and you should be able to select the correct one. Moving on here, 11, again, very similar to number 9, number 6, and number 5. Number 12, and if I have time, maybe I'll do one more of those, because there's so many of those 11, 9, 5. All of those are so similar. If there's time at the end of this video, maybe I will go back and do one. I just kind of doubt I'm going to have time. Now, looking at this next one, number 12, we have which polynomial equation has roots positive and negative square root of 7 and positive and negative square root of 5? Oh, I square root of 5. Sorry, I missed that. So I'm thinking, okay, well, how am I going to get a positive root 7 and a negative root 7? Well, that's where you just have to think, okay, you can really think of this in a few different ways, but that's saying that at one point you had an x plus root 7 and an x minus root 7. And then you can go ahead and multiply these out, whether it's in the box or just foiling. When you do this, x plus root 7 and x minus root 7, when you do this, I'm not going to show this, hopefully. Well, I guess it doesn't take long to show this, so I can show that x times x is x squared, negative root 7 times x, that's negative root 7x, and then x times root 7, that's positive root 7x. So you should see right away those will cancel each other, and then root 7 times negative root 7, well, that's just negative 7. So when I multiply these out, I just get x squared minus 7. Okay? And again, it's saying which polynomial equation. So on your test, this is going to be a multiple choice guy also. And then you're doing the same thing for plus or minus 5i. Okay, so you're thinking, well, if I have that, then I have an x plus I root 5, and I have an x minus I root 5. Okay, multiply these out. I'll do it real quick. We have an x plus I root 5, x minus I root 5. Okay, this is x squared, x times x. I get an x times I root 5 and x times a negative I root 5. So hopefully we see those are going to cancel right away. Not even going to write them in there because x times a positive I root 5, and then I get an x times a negative I root 5. Those are going to end up canceling each other again. Now down here, I get a negative I times a positive I. So that's a negative I squared. And root 5 times root 5, well, that's just going to cancel the roots. So that is 5. And now this is confusing because I squared is negative 1, but it's a negative I squared. So this really is a negative 1, which really is just a positive 1. So positive 1 times 5 is just 5. So that means my other binomial, when I multiplied this out, remember negative 1 is just a positive 1, so it's really just x squared plus 5. And then lastly, to find my final polynomial, I need to multiply these final two out because it's going to be multiple choice and they're all going to look completely in standard form like that. So I have an x minus 7 times an x squared plus 5. Hopefully you don't need me to show this, but I can do it quick. X squared times x squared, that's x to the fourth. X squared times 5, 5x squared. 5 times a negative 7 is what's over here. That's negative 35. X squared times negative 7, that's negative 7x squared. When you combine your like terms, well, there's only one x to the fourth. 5x squared minus 7x squared, that's negative 2x squared. And then minus 35, that is your answer there. Okay, number 13. This one, you are solely using Desmos. And there's a few ways of doing this. You can, honestly, the easiest way is if it has a volume of 2,500, this is similar to a test question that was on Module 3. If you have a volume of 2,500, you can just replace the v of x with 2,500, type in 2,500 equals all of your equation. When you do that on Desmos, you're going to see a line that appears right on x equals 1.5 and x equals 1.5 only. That's the answer you should get. Okay, moving on to a cubic function f of x is shown on the graph. Okay, which root has multiplicity 2? Well, you're thinking, okay, which is my double root? That's what that is saying. Multiplicity 2 is like if you had a root squared at any point. And that's going to happen. A double root, we can see anytime you hit the axis and bounce off, tangent root, double root, that's what it looks like. So at x equals negative 1, that's our root with multiplicity 2. Okay, and then what is the equation in factored form? Well, if we have it x equals negative 1 as a double root, that means that's going to be an x plus 1 because negative 1 is what makes this equal 0. And then it's a double root, so it's going to be squared. And then my only other root is at positive 2. So that means, well, positive 2 is going to make x minus 2 equals 0. So that's how I know I have an x minus 2. That's all there is to it for part B. And then lastly, number 15. How many unique zeros does the function g of x have? Well, it's an x to the fourth, so it's going to have 4. And if we only see two and they don't go through pretty numbers, that means two are irrational because they don't go through nice whole numbers. Two are irrational here. And then